Yes, yes, I don't have any problem.
Okay, so I record this session and I will use it for my YouTube channel. Okay, let me share my screen to you and present screen one. Okay, excuse me because of this simple slides that we have here, but I really made them fast. So this course will be about computer networks. There are some approach. If I pronounce your name correctly, Anitya. Yeah,
Aditya,
Aditya. Yeah.
Aditya.
Okay. We have some sort of approach to computer networks. Top-down approach, bottom-top approach. There are also books written for this course with this title, Top-down approach to computer networks. Okay. There are also other types of approach, for example, computer architecture to computer networks. For example, you go from how to build a computer to how to build a network of computers. And another one is a historical approach to uh, computer networks. It means that they start by telling how computer networks developed and like that. But our approach would be a demo first approach, which we are looking to this course really applicative, and we try to have fun with it. Okay.
Yes.
Okay, there are two types of networking. This is active networking and passive networking. Do you have any idea what is active networking?
Uh, no, that's I'm using this one.
Um,
Wireless type.
no. Active networking means any software commands, configurations, and anything related to software about networks. Okay. So, for example, when you
Yes.
start to configure a router, you are an active networker. Um, and passive networking definitely would be cabling, data center design, physical arrangement of devices, and etc. Passive networks. Let me talk about passive networks, and we'll go for another active and another parts. Passive networks. What we call a computer. What is a computer? Buddy, would you
Can you
please?
repeat? The voice cracked.
The voice cracked. Okay. What is a computer? Do you have any definition of what is a computer?
Um, it's it helps to make our work utilize. It is efficient. It makes our work efficient.
Okay, yeah, it is application of the computers. What you are talking about is application of the computers. Any device containing a CPU and RAM is technically a computer. Okay, CPU is the central
And
processing unit, means the mind, the brain of the device. And RAM is the random access memory. So these together may technically make a computer, a basic computer. So maybe we need another part called I/O to make it a functional system, input and output. So any system with input, output, and central processing unit and a memory is technically a computer. So your calculator is a computer. Your printer is a computer. Your telephone is a computer. Okay.
Yes.
Software engineers call computers machine. So when you hear machine, it means a computer. Software engineers use this word machine. For example, machine learning, it means artificial intelligence for computers. It is you know, they mean computers. Servers in networks, they call computers clients. Okay?
Yes. Yes.
And servers are also clients, and printers or LAN telephones are also clients. So every intelligent thing in a network of computers is a client. Okay? So what it is not a client? For example, the cables are not client. They are the media. They are the medium. Okay? So media would be Cooper cables that we use commonly in LAN networks, or in mobile networks, wireless is the main medium. For example, in BTS or anywhere else. So let me show you a demo. The software I'm using here is the Cisco Packet Tracer. Okay, let me reopen it. Remember this software, Cisco Packet Tracer. Do you know Cisco?
I've heard it.
Excuse me?
I haven't heard about it, but didn't know
Okay.
anything.
Cisco is a company which makes it's around, I think, 40 years that they are building routers, switches, and network telephones and everything else. Okay, is a really giant company. They made this software to help
Hmm.
people who don't have their devices. For example, these are their devices. These are router, for example, 4321. This is one of their devices, their products. They provided this software for us, which we don't want to buy a real one, which is really expensive, to be able to test its functionality and learn how to work with it. So we use this software as a kind of simulator to learn how to configure and build a network of computers. So network is a word in mathematics, means a group of things connected together. So technically, if we use two end devices, I mean clients, for example, one server and another one a PC, and connect them using a, for example, Cooper cable, if we connect them, we can see two green lights on their network card. So the first thing that we do in a computer network is to configure an IP address. So I go to desktop tab and I set an IP address, for example, in this format, 192.168.1.1. And I will talk about the subnet mask and other configurations later, but we want to see a demo first. And I will configure my PC also. It's not necessary because we have the server's IP address, but here I'm gonna set another one. So here on my server, I can configure an HTTP device, for example. On HTTP server, do you know HTTP? Hypertext Transfer
Hypertext
Protocol. Yeah.
transfer
So
protocol.
that's right. So if I go on my PC and use my web browser, which IP address should I enter here? 192.
Sorry.
Which IP address? Which URL should I enter here? 192.168.1.1. It is the IP of the server. That is right. I'm on the PC. I'm pointing to the server. So if I press go, as you can see, I can see a web page here. This web page is right there. So here I can say hello Aditya and save it. Yep. With the same name overwrite? Yes. Okay. So if I go back to my device and use my web browser and go to that URL again, you can see hello Aditya. Was it cool?
Yes.
So how can we use this? If I was on the server and if I open a web browser on the server itself, which IP address should I enter here to access the web page? Do you have any idea?
The one which is integrated on the server.
Excuse me, the voice crashed again.
The IP address which is integrated on the server.
We can use at least two IP addresses. One is the IP address we use on the second device. It will work. Excuse me. It will work. Okay. Another IP address that we can enter is 127.0.0 and 1. This will also work, as you can see. 1.0.0.1. It will work. What is this IP address? This is pointing to the own device. Everywhere it is the standard that this IP address is pointing to the device itself, okay?
Yes.
So we call this address also localhost. It has a domain connected to this. It's called localhost. I have this is my PC. I have a web server running on that, just like any other real server. It has a web server, so I can open my Firefox. If I enter localhost here, you can see my web server. So let me show you some demonstration of it. If I create a HTML file here like this and write your name and exit that, and if I refresh this URL, you can see your name here. So it means that I have a web server running on my computer. And also I can use active server languages like PHP. I can use active server languages like PHP that can allow me to run complicated softwares and complicated calculations on my web server. For example, if I say echo 1 plus 1 and save this file and go back to my, and here I have to use index.php file, it will return 2, which means this one, 1 plus 1. So this is a kind of active server page. We call it a dynamic web because it's running a program on a web server and it's processing my pages before serving it to the user. Okay.
Yes. I have a question.
Yeah, please.
If I write the same thing that localhost and index.php, it will shown in my PC also.
Can I see that? Can you share your screen, please?
No, I am using phone. I'm using mobile.
Okay. So it will not. So it doesn't show anything up here. Am I right?
No, if I write the same thing in my PC, it will show the same thing.
It will not show the same thing, you mean?
Uh, just like that you have written. If I also type like that, and if I type like that, and it will show the same thing as yours
No, it will
if
not.
it's written on mine.
No, it will not, because I
Okay.
have a software installed on my computer called Apache Web Server. Okay, this is the
Oh,
software which I installed on my computer called Apache HTTP Server. You can install it on your computer. Also, there are better solutions for you if you want. It's called VAMP. If you are using Windows, you can use VAMP server. VAMP server is a it has an installer, and it's not that much complicated. It's pre-configured, and you just next install and you can use it. Okay, so you have to use VAMP server before um, accessing that URL on your phone or on your device. So it will not show anything for you if you type localhost on your device. But let me show you something else. We have another device here. This is the PC, same as your PC, that has an IP address. We know what is the IP address. It's 12. If I go on my web server and request for 192.168.1.2, okay, it will show me an error called server reset connection. It means that there is a server in that address, but it doesn't support this protocol. Same as the error you will see on your computer, okay? If I put an IP address that doesn't exist here, it's the bug of the software that says server reset connection. But for example, if I go on my computer, on my real device here, where is the Firefox? If I go on my real device and ask for a IP address which does not exist, it will show nothing up. It will say unable to connect. But if I say my own device, it will not HTTP, it will load my own device. So how can I figure out that there is a device online there? I can go on my server and use its terminal and say ping 192.168.1.2. Let me say command prompt ping 192. Okay, as you can see, it's replying to me. That other IP addresses will not reply to me because they don't exist. So the first thing that we use in troubleshooting of a network is to ping the device. Okay,
yes.
let's test it together. For example, if I want to see if I have access to Google, simply I can say ping google.com. Okay, it's replying to me. It means that I am connected to the internet. But here on this virtual Windows that I have right here, this is a virtual Windows device I have here, that if I open the CMD, the command line, and if it doesn't have any network, if I say ping google.com, it will say ping request could not find the host Google. Let me connect to the device again. Let me connect to the internet again. It's connecting to the network. So if I say ping google.com, it will reply. So this is one of the basic troubleshootings we can do with command line. Was it nice?
Yes.
Any questions up to here? Do you want to know how ping is working?
You can explain. Yes.
Ping, it's a kind of simple packets. What do I mean by packet? Let me see. If I remember to don't close the Firefox, this will be really nice. So, what is a packet technically? When you want to access, for example, a web page from a server, you will make a request at first, and it will send the thing that you are waiting for as a response. We call any of these requests a collection of packets. They are made of a collection of packets. Packets are 0 and 1s that we send on cables to our neighbor, to another computer on the network. So let me show you any image of that, if there is any network packet. I don't want this. I want a better one. For example, let me see if I can use Packet Tracer to show me how it is working. Simulation, okay, it's so nice. Reset simulation, reset the thing. Okay, this is a kind of simulation of the packet, what it is. So if I play this, you can see that at first they are sending something together. If I ask for a web page on this device, let me see. If I ask for a web page on this device, you can see how it is working and how packets are sending to each other. So let me see. As you can see, there is a packet processing here, and it will be sent to the server. Okay, it will load it, it will download it on the server, and it will process the response and will return it back. And here you will have the web page loading. Okay, there are other parts of this response returning. It's a really okay. When they are okay with everything, and when they are finished, you can see the response. This is what we call it a
Nice.
packet. It is what we call it a packet. Small parts of data, small chunks of data, which helps us transform the information finally. We call it packet. There are softwares which you can
Small
use to
type of
see. Excuse me, would you repeat?
pack small bits. It means.
Yes. I have another software here. I don't know if it's. Let me see. It is not one. No. Let me see if I search for it. I can find it here. Okay, I don't have it really. I can download it. It's called Wireshark. Let me go to my apps store. Wireshark. So I want to ask you to download the Wireshark on your computer and try to work with it. I will send this your homework maybe in the chat. So to download and install install Wireshark. Another one is to use ping command on your computer and try to figure out how it is working. And it's installing Wireshark, waiting for it. Does it have a GUI? Qt version, okay. Yes, would you? Did you have any question?
Is it a type of terminal?
Would you please talk slower?
Is it a type of terminal?
It's a type of kernel, you mean? Is it a type of? I didn't hear the last word. Is it a type of
Terminal.
terminal? Oh no, it's not a type of terminal. It's a GUI, graphical user interface software. Waiting for it to download. I don't know. Wireshark will show you the really deep details about your network. Let me see. It will help us to sniff what is going on in the network. Hackers really like it. If I have some screenshots of this software, yeah, this is. You can see what is going on in your computer. It's really fun. Installing 19%, 91, 92. Not ready yet. 96%, 97%, 8, 9. Okay. Are you a Windows user or are you a Mac user?
Windows.
Oh yeah, it's better for learning networks. Using Windows is really better. So this is the Wireshark. As you can see, I can see my different network cards. I can see also my Bluetooth device, and I have I can see my wireless device, but it will not show up anything here. As you can see, the diagram is showing nothing because my software doesn't have permissions to access to the wireless network. The way to solve this issue is to use my terminal to open Wireshark as administrator, what you call it, run as administrator in Windows. So if I run it as administrator, you can see these diagrams are working. And here, if I open my VLAN, here you can see that any kind of packets which is sending from my device to any other device, you can see them, it's showing up here. Okay, so I can have, for example, some kinds of filters here that can filter only HTTP requests. For example, if I open a website, for example, here, if I open a website, for example, my own website, which is using HTTP, as you can see, it sniffs all the requests which is going between my website and my device. For example, this is the images. Okay, this is other parts, and this is the full details of what is going on between my computer and that website. For example, this image, if I this, I can see really deep details. For example, this is the URL of the image file which is opening here. It's this one, it's this image. Wireshark will show you really deep details about your network. If I remove this HTTP, you can see that my device is sending a lot of data to other devices on the internet. Are you online? Do you have my voice?
Hello. Oh, I missed that. My internet got disconnected.
Do you have trouble with internet, or I have trouble?
No, my internet got disconnected.
Okay,
Sad.
so my device is sending lots of data to other destinations, and maybe these UDP packets, can you guess what this IP address is and where it is sending this data? Do you have any idea?
Server.
Yeah, where it is. It's a kind of, the protocol is UDP. As you know, the HTTP that we used here, HTTP packets are using this protocol, HTTP. What is that UDP? Do you have any guess that why my device is not connected to anywhere and I'm not opening any web page? What are these communications from my device to an endpoint? What it is? Let's check, okay? Let's see where it is. IP location. Okay, what? IP location, which converts IP addresses to their location. So let me see. 142.250.82 and 1. Let's see where it is. This is Japan. It is google.com. It is the IP address of Google. Do you know what is this UDP packets right here? It is our connection. This is our Google Meet session, which is sending these amount of packets every moment that help us hear each other. Okay,
Yes.
when you are watching a Instagram live video, you are using UDP. When you are browsing a web page, you are using TCP. Okay, so at this moment you can find the difference between a TCP and UDP. UDP, as you can see, when you open your connection to the server, you can send the response sequentially. But in TCP, you have to be sure that the client received your previous packet. So UDP is really faster, but TCP is really more stable. We use TCP to share important data like web pages, but like images also. But UDP is used for videos. So if you lost some frames of the video will keep going, and you will not. For example, in a live video, maybe you will have low quality images, but you will have the video going on. Did you get the difference between UDP and TCP?
Yeah. YouTube videos will be TCP or UDP.
YouTube videos, because YouTube has two kinds of videos. First kind of videos on YouTube is TCP, is using TCP, because you can see a loading page and it will wait for you to receive the video and show you the next frames. But if you are watching a live video, you are using a UDP, because it's really important for you to be live with the streaming center. So there are two kinds of videos on these media streaming servers. One kind is TCP. For example, when you are, if YouTube I think is blocked and I don't have access to YouTube right now. Yeah, I have to use a VPN. I have to use a VPN to connect to YouTube. Okay, I'm good guy. For example, here, these videos, for example, why they are all naked? I don't know. Here, oops. For example, this video, as you can see, it loaded all those video frames. This is a kind of TCP video, okay? But here on this website, which is a live streaming website like Twitch, for example, if I go to live videos, where it is? Where is the live part? Yes, here it is. So, for example, here in this, these gamers are streaming live videos. This is using UDP because I have to see it live. I have to see it without any. You can see that video quality is lowering and going up on my network quality. Am I right? So this is the difference. If I cannot load, if my network fails on a YouTube video, it will wait for me to download it. But here, no, it will not wait for me. So let me show you with another kind of. I will turn off this packet tracer also. Let me see if I can find another one. Google.com. TCP is UDP GIF image. Okay. Multi-tools, type animated. Okay. I think it is an animated video, which it's really slow. Okay. No. I cannot find an image to show the difference visually. Let me finalize this subject. UDP is faster than TCP, but TCP is more stable because TCP will wait for your previous packet that your device that in a connection between a server and a client, the client have to acknowledge that I have received this packet, and if it acknowledge that one, it has to send a response that I have received your packet. And if the server didn't receive this response from client, it will not send the next packet, and it will repeat it if it fails. Okay.
Yes, yes.
Okay. So I think it's enough for today because we are running out of time. Please tell me your feedback about this session. And if any question you have, I'm here to answer.
Full form of UDP.
Excuse me?
Full form of UDP.
Okay, full form of UDP, you mean?
Yes.
Okay, this is the question of, okay, UDP packets. Let me see if I can find any image about UDP. UDP packets. Okay. UDP packets vs TCP packets. All those, do you remember those packets in Wireshark? Do you remember them? Let me show you again. Let me show you again. These are UDP packets, and that is a TCP packet. Let me show you the TCP packet here. Let me see. HTTP, okay. Okay. Opening a web page. HTTP. Okay. This is an HTTP packet, as you can see. If I double click on that, you can see the packet right here. And this is those 0 ones that we know. It's in another form. It's in another format. Let me show you a calculator. If I enter 10, it will be 1010 in binary format, and it will be A in hexadecimal format, and it will be 1-2 in octal format. Okay, so if I say, for example, if this is my input, would be a hexadecimal format, for example, E4 would be 1010011000. Okay, so this part is this 0 ones, but it showed in hexadecimal format to save I mean space here, more simple to read. And this is the decoded format in human readable format. For example, connection keep alive. If you want to write connection keep alive in computer language, would be this. So this is a packet of a TCP request. It's like this one. We call it a datagram. We call this part a datagram. Okay.
Yes.
If I go to a UDP packet here, as you can see, the datagram is really more smaller. Okay. So because of this, we can send lot of more UDP packets sequentially to have this. For example, our voice connection is using UDP, so they are using, it's because its datagram is smaller. As you can see, this is the datagram of a UDP connection, which starts with source port destination, which contains source port, destination port, length, header, and data checksum. But TCP's packet has source port, destination port, sequence number, acknowledgement number, as I described before. What is acknowledge? Data offset, this is a reserved part. Flags, I will tell you what is window size, I will tell you header and data checksum and a lot of other parts and options also. So as you can see, it's very larger than a UDP packet, and here in Wireshark we can clearly see that they are really different. They are larger, really they are larger. And so here this part above this details part, this part is showing us the data inside the datagram in separated and in a nice format. You can see that it's really more beautiful. So here you can see those parts of that datagram really clear here. So this is the visualized format, and here it is the real format of that data. And I mean this part. This is the visualized and this is the real format. Okay, for example, the destination is this one, destination, and the source is something else. And here it is the source, you can see source, and for example, the length and lots of other things. Okay, do you still have any question about UDP?
If someone is live streaming on YouTube, that will be also an example of UDP, I think. So,
If someone is live streaming on YouTube, it is a UDP, yes. If someone is live streaming on Twitch, it will be UDP connection. If someone is having a video call on Google Meet, Skype, it will be a UDP connection. But any kind of stable connection, like browsing a video which is offline, for example, YouTube videos. If you're downloading a file from a file server, if you're opening an image, they are definitely TCP connection between you and that server, which is serving that file. Oh, let me ask you a simple quiz. What is the type of connection of a game server, which we are playing a shooting game? What is the type of that connection? Do you have any idea?
live only, I think so.
Yes. Can you say, is it TCP or it is UDP?
UDP?
Yes, correct. If you're playing Counter, for example, Counter-Strike, did you play Counter-Strike ever? It's the game.
No, not my bad. I didn't play that.
It's the game of our.
Actually, I have a very low-end PC.
Oh yeah. No, it will run on any kind of PC. It's
Mine is
really
2
old.
GB RAM. That's
For example, this game is using. Let me show you. I just stopped sharing. Counter Strike. Let me show you the entire screen. Yeah, this game is really use low. It needs really low infrastructure to run. It's really old. Has the same age as me. This game uses UDP for its shooting. Mostly shooting games are using UDP because they have to be fast. Network games have to be fast. so they use UDP. Okay, so please for next session, please use ping command on your computer and use Wireshark to monitor what is going on between you and other devices when you are doing different things. For example, playing games, having a Skype call, viewing web pages. Please take a look at Wireshark every moment, okay?
Can you repeat the first application which you said?
Ping command on your computer. I just
Oh,
wrote it in chat
yes.
box.
Yes, yes, yes.
Okay. These are
Any
two
website I
tasks.
can type?
Excuse me?
If I type ping
No,
youtube.com.
no, no. No, 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 no. It's not a website. It's a command. For example, if you say ping google.com, it will show you that you are connected to google.com and what is the IP address of Google. Okay. If
Oh,
I say
that I'm
ping microsoft.com, it will say that I am connected to Microsoft and this is its IP address. If I say ping, for example, a server in Iran, aparat.com, for example, this is the IP address of aparat.com. Okay.
yeah, clear.
And as you can see, if I request for a server in Iran, which is geographically near to me, I will have a destination of 63 milliseconds to there. But Microsoft, which is far, far away from me, it's at United States, I will have a, for example, Google, I will have a delay of 100 milliseconds. So this means that this server is really near to me and this server is really far away from me. If I request for my own computer, you know that I have to write 127001. It will have less than a millisecond delay because it's connecting to itself.
How can I find my IP address?
How can you find your IP address? You cannot find it with any command on your computer. You have to go on a web browser, for example. You can go on a web browser and write what is my IP. If you say what is my IP, you can use one of these websites. For example, whatismyip.com, and it will show your IP address. Okay. Hello.
Got it, got it.
Okay. But everywhere the 127.0.0.1 is your own IP address. Everywhere on this planet, this is your own IP address. Okay? If you
Yes.
ping, you can ping yourself with ping this number. If you ping yourself with this, you can see that you have a delay of really loud delay. Let me zoom on it. It's less than a millisecond here delay when you want to connect to yourself. And if you want to connect to a server in your country, you will have a delay of less than hundreds of milliseconds. And if you ping a server outside your country, you will have a delay of 200 milliseconds, 100 milliseconds, and something like that. So for next session, please do another task for your next session would be install packet tracer and connect two simple computers together with IP address. Computers together, computers together, and set IP address for them. Okay, so for next session, please do these tasks. And if you had any question, please ask in Instagram direct.
Packet Tracer is an application.
Yes.
Connect to
Cisco
simple computers.
Packet Tracer. If you please install Telegram, it's really better for me. I can really answer you fast. I'm not always connected with Instagram, so if you install through Telegram, it will be really, really nice.
Yeah, I am on Telegram.
Yeah, you are. So, what's your ID? Or send me a message. Send me a message on this ID. Okay, slash.
I think there would be a number. Oh yeah, I got that.
Okay.
Just a second, give me.
If you have any further questions, you can ask me on Telegram. Our next session would be today's Wednesday. Our next session would be on Thursday, excuse me. Thursday. Okay, we will match for the next session in Telegram. Any questions?
No, I don't have any. It's all clear.
Okay, so please send me a message on Telegram, and bye bye.